All right, we're here today to talk about sections 6.3 and 6.5. The first type of homework question looks like this, where you have they're asking whether or not these are true. Well, on the left side, you have n squared plus 25. Over here, you're squaring this binomial. So if you had n plus 5 squared, that really means n plus 5 times n plus 5. And if you multiply that out, you get n squared plus 5n plus 5n plus 25. So over here you get n squared plus 10n plus 25, and over here you just have n squared plus 25. So you have that double middle term right there. So that's why these are not equal to each other. Okay. Now we're going to skip through here and do a couple of these questions. Now it says factor the trinomial. Okay. So we have 4x squared minus 12x plus 9. So the purpose of this section is to recognize special patterns. All right, so this one's of the form ax squared minus no, I take that back. Of the form ax minus b squared. In other words, it's a perfect square trinomial. It's the same thing times itself. So how would you know that? Well, you might look at that and say, oh, 2x times 2x gives you 4x squared. And you might say, oh, 3 times 3 is equal to 9. So therefore, now I have a negative middle term. So if I say 2x minus 3 times 2x minus 3, let's see if that works. Well, you have 2x times 2x, that gives you 4x squared, and you double that middle term. So you have 2x times negative 3, it's negative 6x, but you really know it's the same term again, minus 6x again, so that's going to be plus 9. So if you wrote that whole thing out, you're going to get 4x squared minus 12x plus 9. So you get this from recognizing a pattern, and the pattern is that you have some x minus b and some x minus b. That's called ax minus b squared, perfect square trinomial. So you see how it's the same term twice. How do you know that? Because if you multiply these two, you get half the middle term, because you know the term doubles when you multiply it out. And you know negative 3 times negative 3 gives you 9. You know 2x times 2x gives you 4x. And you know 2x times negative 3 is negative 6x, but you add it twice and it becomes negative 12x. So after a while, you get to be able to recognize those patterns. All right. Take a look here, another one like that for you. So for instance, if you have this one down here, if you had x squared minus 12x plus 36, right? Well, you ask yourself, well, this is kind of like 6 times 6, and this is kind of like x times x, and then you have a minus 12x, so maybe it's minus 6. So you try x minus 6 squared and see if that works. So it's the same format. You say, okay, I'm going to get x squared minus 6x minus 6x. Oops. Sorry about that. Plus 36, and you say, oh yeah, that works, x squared minus 12x plus 36, and after a while you'll begin to see that the middle term is always going to double when you have a perfect square trinomial. That means you're squaring a binomial. That means the same binomial times the same binomial, and that gives you back to the original, so you know it's correct. So this is called the factored form. Okay, the factored form. So it's going to be, answer is going to be x minus 6 quantity squared. That's the final answer for that one. All right. The next type of problem asks you to factor things out first, right? So if you have this guy over here where it says 3x squared minus 12, so let me just write this clearly. You have 3x squared minus 12. Some of you guys forgot to factor out a greatest common factor first. That's why we learned that. These sections go in order for a reason. So if you take it out of 3, you're going to get 3 times x squared minus 4. Now this is a special pattern. It's called the difference of two perfect squares. It's where, unlike over here, this is perfect square trinomial, it looks like it. This is something squared minus something squared, where these are both perfect squares, okay? So you might remember this is x plus 2 times x minus 2, and you just bring the 3 down. So this is the case where if you have two perfect squares with a minus sign in the middle, that is equal to, you could say it's x plus b and then times x minus b. Alright? And basically you put the square root of a here and the square root of a here. You don't really need that, but basically if you had x squared minus b squared, it's going to be x plus b times x minus b. Now, if a is a perfect square, then it's going to be the square root of a and the square root of a here. Example. Let's do one like that. You have 49x squared minus 25. Okay, so here's a perfect example. You have 49x squared minus 25. So you should notice right away that that's a perfect square. 7 times 7, 5 times 5. Okay, so this is a case of ax squared minus b squared. So it's going to be square root of a, which is going to be 7x plus 5 and 7x minus 5. And then the reason why you have opposite terms is because the middle term is going to add to 0. Okay, that's why there's no middle term. Unlike these trinomials that have that double middle term in them, this does not have a middle term. There's only two terms. Okay, so 49x squared minus 35x plus 35x, right? Minus 25. So you see the middle terms add to 0. I don't use the word cancel or FOIL, okay, because I don't have mathematical terms. But just say no. So it's going to be 49x squared minus 25. So that matches the original. So our final answer, if this is the factor, when they say factor, that's the form that they're looking for. All right. Moving on down, the next type of problem you might see is when you have the difference of cubes. Okay, difference of cubes. And that's when you have first term is a perfect cube and the second term is a perfect cube. So what I would do if I were you is make a list of perfect squares and cubes, all right? So down here in the bottom of the paper, you want to say something like x squared. So you're going to make a list. You're going to have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144 should be enough to get you started. And then perfect cubes, you should have 1, 8, 27, 64, 4 times 4 times 4, 5 times 5 times 5, 125, 6 times 6 times 6, 216, 7 times 7 times 7, 343, 8 times 8 times 8, 5, 24, 9 times 9 times 9, 729, and 10 times 10 times 10 is 1,000. You don't have to memorize these. Just be organized, have them down on your paper, be ready to use them. They're going to save you some time when you see these problems, okay? So this one over here, what do I have? Oh, difference of square, a difference of cubes, right? So what that's going to be is if you have a cubed minus b cubed, it's going to equal a minus b times a squared plus ab plus b squared. A squared, yeah. All right. And you kind of know that because these have to be opposite signs. The middle terms have to be opposite signs in order for, there's no middle terms at all. So therefore, what's a in this case? A is equal to x in this case. And b is equal to just 4 in this case, because x times x times x gives you x cubed, and b times 4 times 4 times 4 gives you 64. So you put those values in here, you substitute those in, you're going to have x minus 4, and then x squared, a squared, b squared is going to, ab, so you multiply them together, it's going to be 4x, so it's going to be plus 4x, and then plus b squared, so it's going to be 16. So that will be your factored answer, special cases. These are special patterns, factor patterns, that you want to recognize from the way they look. The last time that you might see is the sum of cubes, all right? So if you have the sum of cubes, that's when you notice you have the same number repeated 3 times. So you have, it's the same thing except you have a sum. It's plus instead of minus. That's the only difference, all right? So the formula for that is, you don't have to memorize it. I usually let people use formula sheets, okay? So a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So you know that this middle term, again, these middle terms have always to be opposite. They're always opposite each other, all right? And the b squared is always positive. All right, so therefore in this case, a is equal to 4x, because 4x times 4x times 4x is equal to 64x cubed, and 5 times 5 times 5 gives you 125. That's where all these cubes and squares come in handy. So b is equal to 5. So you use the formula here. So you can have a plus b, you can have 4x plus 5. And then a squared is going to be 16x squared. It's going to be 20x, so it's minus 20x. And then plus b squared plus 25. So this, if you multiply it all the way out, it should give you just 64x cubed plus 125. You should have a lot of terms that add to 0. A squared, yes, minus ab. You're always going to check your answer. A squared, yes. B squared is 25, yes, and minus ab, yes. So that's correct. So if you wanted to prove the answer, you just multiply that out and see if you get back to the original. But you should have a lot of terms that add to 0 here. That's the trick. So I'll stop there for 6.3, and then I'll pick up with 6.5 momentarily.